Graph theory, trees, and spanning trees on page 20. A tree is a graph in which any two vertices are connected by exactly one path. So I think the best way to look at it would be if you removed any one of the edges, would that graph become disconnected? So let's look at this example. Which of the following graphs are trees? Well, I don't think we could say that this first one is, because if I remove this edge right here, wouldn't this vertex still be connected to that vertex? And yeah, all the vertices would be connected to each other. So that is not a tree. In fact, that's a circuit. But on the next one, I think you see if I got rid of that edge, this point would be disconnected. Okay. How about if I got rid of this edge? Well, this part of the graph would become disconnected from the rest of the graph. How about if I got rid of this edge? Same thing, it would become disconnected. How about this edge? Well, that point would become disconnected, so that's a no. And if I remove this edge, well, that would become disconnected from the rest of the graph, so it would no longer be disconnected. So it looks like that this follows the definition. It's a graph in which any two vertices are connected by exactly one path. So this is a tree. Okay. All right, so with this next one, I think you could say, well, what if I remove that path, that edge, would it become disconnected? Well, it's true about that one, but if you'll look over here, we basically have a circuit there. So that's not true for any two vertices. Okay, so this has a circuit in it, so that is not a tree either. Okay? So same could be said of this next one. The right-hand side of this graph is looking pretty good, but the left-hand side, I'm seeing a circuit again. Okay? So that is not a tree. Whereas this next one, if you remove that edge, it'd be disconnected. How about this one? Same thing. How about this one? Yep, it would be disconnected. Same with this one, and this one. So that is a tree. So the properties of a tree is a tree has no circuits, which I think we just noticed. Trees are connected graphs. Every edge in a tree is a bridge. I think we noticed that as well, didn't we? And every tree with n vertices has exactly n-1 edges. A spanning tree for a graph is a tree that results from the removal of as many edges as possible from the original graph without making the graph disconnected. So example 20 is asking for us to find a spanning tree for each of the graphs shown. And it is very important to note that there's more than one spanning tree possible. So another thing I want you to note is if we have 5 vertices, then we should only have 4 edges. Okay, so what if I remove this edge and that one, and that one? Okay, they're all still connected. Each one of the remaining edges is a bridge, so I think we have a winner. Okay, so how about B? I have 1, 2, 3, 4, 5, 6 vertices, so I should have 5 edges. So I think if I remove this edge and this edge, that I have a spanning tree. Okay, with this next one, same thing. I have 1, 2, 3, 4, 5, 6 vertices, I should end up with 5 edges. So I'm thinking about getting rid of this one, this one, this one, and this one.